If you understand the concept behind k-means, you already know that choosing the number of clusters is absolutely central to making the algorithm behave the way you want. But many developers struggle with this step. Choose too few clusters, and completely different groups get mixed together. Choose too many, and your clusters fracture apart like shattered glass. Fortunately, there's a surprisingly simple visual technique that reveals where k-means works best, and a second method that verifies whether your clusters actually make sense. These are the elbow method and the silhouette score. Before k-means can even start, you have to tell it how many clusters you want. 2, 3, 8. Real data almost never tells you the number directly. That's where the elbow method comes in. The idea is straightforward. We run k-means multiple times. First with one cluster, then 2, then 3, and so on. For each value of k, we calculate how tightly the points fit within their assigned clusters. This measure is called inertia, the sum of distances from each point to its nearest centroid. If we plot these inertia values, we get a curve that drops sharply at first, then begins to level off. That bend, that sudden change in slope, is the elbow. And the value of k at that point is usually the best choice. It marks the moment when adding more clusters no longer gives meaningful improvement. But sometimes, the elbow isn't obvious. The curve might be smooth, or several values might look equally good. So we need a second opinion, a way to check the quality of the clusters we create. That's where the silhouette score comes in. The silhouette score measures two things at once: how close a point is to other points in its own cluster, and how far it is from points in the nearest neighboring cluster. If a point sits deep inside its cluster, far away from the others, it gets a high score. If it's hovering near a boundary, or worse, closer to another cluster, the score drops. Scores range from -1 to 1. Values near 0 mean the point isn't sure where it belongs. Negative values usually mean it's in the wrong cluster entirely. By averaging the silhouette scores of all points, we get a single number telling us how well-defined the clusters are. The k with the highest silhouette score is typically the most meaningful. So here's the workflow. Use the elbow method to narrow down a reasonable range. And then use the silhouette score to confirm which clustering is truly the best. And remember, distance defines structure. Evaluation keeps it honest.